In today's class, we will start to utilize all those theoretical parts which we have learned in the last class. That is, we will be given some differential equations and we are to find out the canonical transformed format of it. So let's start with the first problem. This problem is saying you are given that del 2z del x2 minus del 2z del y2 is equal to 0. Now you have to find the canonical form of this equation. Now to begin with, we will compare it. This is actually 1 multiplied with r plus 0 multiplied with s minus 1 multiplied with t plus 0 is equal to 0. So you see that your capital R is equal to 1, capital S is equal to 0, capital T is equal to minus 1. So what is the value of S square minus 4RT? So this is clearly is equal to 4, right? Now this is greater than 0, so this equation is hyperbolic. The next step, we have to find out our u and v. For that, we need to solve this quadratic. R lambda square s lambda plus t is equal to 0. That is, this is gonna be lambda square minus 1 is equal to 0. So lambda is equal to plus minus 1. So the first equation to be solved should be dy dx plus 1 is equal to 0 and dy dx minus 1 is equal to 0. Solving, we have y plus x is equal to c1 and we will write it as u, and y minus x is c2, we will write it as v. So now we will check the different differential parts, like ux is 1, uy is 1, vx is minus 1, vy is 1, uxx is 0, uyy is 0, vxx is 0, vyy is equal to 0. So from there, if we try to write all those formats, so our equation, you can follow two methodologies. Now you can differentiate all the things and construct your equation, or you can simply, if you are able to remind the capital A, capital B and capital C like this format, so you can actually directly put your value of capital R, S, T and Ux, Uy, etc. and you can get what will be your A, B and C. So this may be a way. Another way, you can find out simply the P, Q, etc. and then replace that. So I'm going for the second method. However, if you can remember the construction of capital A, capital B and capital C, then you can go for the direct input method as well. So using this, see, P, that is your ZX, that should be ZU UX plus ZV VX. Now this is ZU UX, so this is ZU directly, and VX is minus 1, so this is ZV. Q is ZY, so ZU UY plus ZV VY, this is simply ZU plus ZV. Now R is ZU UX square 2ZUV UX VX ZVV VX square ZU UXX plus ZV VXX. Okay, and sorry, I mean then is another term z, sorry, no, this all. And so you see this is z u plus 2 z uv, there will be a minus sign, and z vv. See, I know that my s, uh, okay, let's calculate, but actually this s will not be required anywhere, right? So make it simple. So t is equal to, all these things are replaced by y, so this is simply ZU plus 2Z UV. Why? Because Vx is minus 1 but Vy is equal to plus 1, ZVV. So if we combine, simply the equation was R minus T, and this is, you see, this minus this, so 4ZUV is equal to 0. That is, your ZUV is equal to 0, and this is the canonical form of the given equation R minus T is equal to 0. Okay, so the first problem is done. Next go for the second problem. Second problem of the same method is 3zxx plus 10zxy plus 3zyy is equal to 0. So r is equal to 3, s is equal to 10, t is equal to 3. First we will check the value of the discriminant, and that is s square minus 4rt. So s square minus 4rt is now 10 square minus 9 into 4, 36, and this is equal to 64, which is greater than 0. So what you see, that your type is hyperbolic. Fine, then we have to construct your u and v, and for that we will solve r lambda square plus s lambda plus t is equal to 0. That is 3 lambda square plus 10 lambda plus 3, and that gives 3 is equal to 1 over 3, 5 plus minus, this will be root over of 64, which is 8. So actually we will write a 16 here because we have already divided by 2, right? So 1 by 3, 5 plus minus 4. So one result is 9 by 3, that is 3, and another is 1 by 3. So what we have to do now, we have to solve dy dx plus 3 is equal to 0 and dy dx plus 1 by 3 is equal to 0. Now see, this is giving us y plus 3x is equal to a constant which we are taking equal to u, because u is another constant, and 3y plus x is equal to some constant, and this we are taking to be v. Now follow that ux is equal to 3, uy is equal to 1, vx is equal to 1 and vy equal to 3, and uxx, uyy, vxx, vyy all are 0. So simply now we are going to, now for this problem I am directly using the forms given. Okay, so see, these are the forms. So a should be equal to I guess r is equal to 3, ux is 3, so 9 plus 10 into 3 into 1 plus t is 3 again, and uy square, so it's 1. So what do we see? This is equal to have I made some mistakes? Well, sorry for that. There should be a minus 1. So these results are turning to be this, and there should be some minus signs. Extremely sorry. So for here this is equal to -3, and here this is equal to -1, ux and vx, right? So whenever we were imposing this form, say, follow that this will be plus, but this will be a minus, and this is plus again because we are taking a square. So here you get 27 minus 30 plus 3, which is equal to 0. Now capital B, this is 2r, so 6 multiplied with -3 minus 1 plus s, that is 10, ux is -3, vy is 3 minus 9 plus uy is 1, vx is -1, so this is -1. Then 2t, so 6 multiplied with uy vy is 3, so this will turn to be 18 plus 100 plus 18 again, so 136 as far as I am seeking. And last one is c. So c will be r3 vx square, so it will be 1 plus s 10 vx vy -1, and sorry, vx vy is -3, and vy square 3 multiplied with vy square, that is 3 square. So see, 3 minus 30 plus 27, this is 0 again, so you are actually having 136 zuv is equal to 0, that is zuv is equal to 0. This is the canonical form of the given equation. Even you can solve these equations as well. Like, see, whenever you are integrating this equation, first say you are integrating with respect to u, then this is actually del v of zu. So integrating, you are getting zu, and there will be an arbitrary function of u, because whenever you have differentiated this term with respect to v to get this one, this is constant for v, and this became 0. Now you are integrating again with respect to u, so you are getting z is equal to first you have to integrate this, that will be actually see, writing one step, 0 to u, or not to write any limit for that. This is 3 u1 du1, okay, write the limit as well, and plus another arbitrary function which is of v, because whenever you are differentiating with respect to u, this function should act like a constant. So suppose that this at 0 this integration's value is equal to 0, so what you are getting, the integration of this term, which is another function of u, I'm writing it to be phi1 u, sorry, phi1 u and phi2 v was there, so ultimately you can write phi1 u means y minus 3x plus phi2 3y minus x. And similarly, if we go for the last problem, the solution of this problem should be phi1 of y plus x and plus phi2 of y minus x, simply. Okay,